Okay, welcome back for Sea Level Part 2. I'll go ahead and start that. Part 2, and I've got my RStudio open, I've got my script editor, my console, where my plots are going to go, and my environment window. In this exercise, we're going to take another critical look at sea level, and sea level in relation to ice mass loss. So sea level goes up when you take ice that's on land and you melt it and you put it in the ocean. Kind of like putting in ice cubes into your glass. The sea level goes up. And so we're going to go ahead and load in our sea level data again. From NASA, and we're going to be using site again, this one here. And here's our sea level data. And if you remember on the last video, we looked at the slopes of this line and whether or not they were accelerating or not. And we used this data, this FTP server, to get this text data. And we can take this, we'll just copy that for now, move this over, and we're going to load our global mean sea level data. That's going to equal read.table this thing. And remember last time we had to skip 50 lines of header information in order to get this data read into the R program. So if you look over here again, here's our header information. There's 50 lines of it before we get down to header end, and here's our sea level data down here. And we talked about that on the last video. Okay. So we're going to go ahead and read this in. Okay. And we can take a look at the top of that, head of NASA cell. There it is. So we figured out that our third column, which is this column right here, is our year. So we do column 3, and our sea level that we'll be using, we decided was going to be our 12th column. That is, if we look over here again, it says that column 12 is our smooth 60-day Gaussian type filter, global mean sea level, GIA applied, stands for isostatic adjustment applied, with the annual and semi-annual signal removed with respect to the 20-year mean. So that's one we worked with. You could work with a number of these sea level ones, just read about what these are, and that corresponds to these different columns here, what type of sea level measure we have. So here we go. We could do that, and remember that we could do a simple plot of the year and GMSL. Type equals line equals 2. Make sure that we know what we're dealing with here. Oh, you're not. I guess I never ran this. So let's run all these things together. There it is. Oh, and I had a misspelling here. I got a warning. Tile. Oh yeah, this is supposed to be type. TY type is L. So let's run that one more time. Okay. There's our global mean sea level. Let's see if that looks like what's on the NASA page. Yep, same shape, looks good. Remember before, this one here is referenced to 2005 as 0, it goes from about -40 to 48. And here starts from 0 and goes up to 88. And it's the same data, it's just a different intercept. Okay. All right. Now, what if we wanted to compare this to how much ice mass there was both in Antarctica and on Greenland? Those are two areas where there's big ice caps that we think are melting that have been measured from space. So we are going to go ahead and load the Antarctica mass anomaly. And no moly. Okay. Can't spell anomaly right. There we go. Okay, and where are we going to get that from? Well, if we go back here, back to our sea level page, when we scroll up, we also see ice sheets. We're going to click on ice sheets, and we have our Antarctica mass variation. So this is the loss in ice mass in gigatons, reference to 2002. And we have the same thing with Greenland ice mass variation. So we're going to get these two data sets, similar to the way that we got them before. So got the sea level, so we're going to do that. We're going to go ahead and grab this FTP text file. Here it is. Here's Antarctica mass, data from the GRACE JPL RLM M1 Mascon Solution version 2. So this is from the GRACE satellite. This is Antarctic ice trends. If you use these data, do these things, and we're going to go ahead and copy this and put that in here. So this is now our NASA ANT this is going to be a read table of this thing, and we do have to skip some lines, if you remember, right? So here's all the lines that we got to skip, and it turns out that we need to skip, if you count them up, we need to skip 32 lines of header information. So let's go ahead and read that in. Okay, let's look at the head of NASA ANT mass. So there's year, and then there's two other things here. What are those things? Well, what are those things? So there's our year, column 1, year, column 2, Antarctic mass, gigatons, and number 2 is the 1 sigma uncertainty. So it's a measure of uncertainty around that. We're just going to be focused on the second one, which is the average ice mass measured at that time. So we can put in create a couple variables here. This is our ANT mass year. This is NASA ANT mass column 1, and just copy and paste this and edit it. Our actual Antarctic mass is, oh, I'm sorry, this should be column 1. That's our year. That's this one here. And this should be column 2. Okay. Good. All right. And let's just make sure that that looks like the way it should. So let's go ahead and plot ANT mass year versus ANT mass. Just a quick plot. Yeah, and let's compare that to what's on the web. There it is. Yeah, that looks like we've got the right thing. Yep, that data looks a lot like that data. Okay, so far so good. Okay, good. All right, so what are we going to do now for our Greenland? Let's load our Greenland ice mass. So our NASA GRN mass is going to equal something, read.table, and we have to get some link to put in those quotes. So we're going to go back to our website here. Here's our Antarctic ice mass variation. We can scroll on down to Greenland since 2002. Okay, so again, go to the FTP. Here it is. Here's Greenland ice data. This file contains values that are anomalies relative to 2002, computed the same way that we got the Antarctic one done. So here's similar headers, time, Greenland ice mass. Here's our 1 sigma. So we got to grab this. We'll put this right in here. And it turns out that we need to skip let's see, what is it? We need to skip 31 lines of header to read this in. So far, so good. And we can just take this code here that we use for Antarctica, copy and paste it, and edit it. So now we want to have our Greenland. Okay, and we want to plot our Greenland mass year, Greenland mass. Oh, Greenland ant mass. Oh yeah, that's wrong. I need to just, this is NASA green mass. Yeah, that's what happens. You got to be careful when you're editing your code. Yep, okay. So here's that data. Let's take a look again at the plot online. Looks pretty similar, right? Right here, we get this little hiccup in the data here where it goes a little faster. Down we go. Okay. All right. Okay, so let's go ahead and try and put these all on the same plot. Let's go ahead and try and do that. So the first thing we want to do is go ahead and let's plot our global sea level. So we're going to imagine a plot where we have sea level and ice mass on the same one to see if they're related in some way. So let's do plot year, which is our sea level mass, or our sea level year. Level means sea level, type equals L, line weight equals 4, Y lab equals our Y label, global mean sea level 2005 ref in millimeters. And our X, yep, okay. Our X label is going to be year. All right, what if we plot that? There it is, familiar plot from the last video. All right, now let's see. I want to have a little more space on this side over here because we're going to add another axis on this, and I'll show you why we do that in a second. But to do that, we're going to use what's called a par command, which is going to change the margins of the plot. So parmar 5, 5, 5, 5, and what this means is our par commands are plotting some plotting handles. We're going to change the margins to have a space of 5, 5, 5, and 5. This is bottom, left, top, right. A space of 5 around the plot. Right now you can see there's more space on the left of this plot than there is on the right, and we're going to make it so that it's all equal. So we're going to run all this again, and you'll see what happens here. Yeah, you'll see that. We've got a nice big border around our plot now. Okay, that's good. Okay. Now what's coming up next? Well, we want to add a plot right on top of this that's going to have our global mean ice levels on these. So we're going to use a little trick here. Actually, first let's just make a plot. So let's go ahead and plot green mass year and green mass type equals L. Equals 4. And our color will be sea green. Okay, so if we make this plot, yep, misspelled this. Let's try that again. Okay, so somehow we want to stick this line on top of this line, but we got a couple issues. One is that our x distances are a little bit off. This is only 2002 to 2018. This one goes further back. Also, our Y values, this is global mean sea level, is different than this one. This is mass over here. So what we're going to do is, you can imagine taking this line and sticking it on here. It would start around 2002 and decline. And then we're going to put the axis for our mass, we're going to stick it on the other side of the plot, on this plot right here. So that's what we're going to do next. So to do that, we're going to come back over here, and we're going to use what's called a par, another par command, new equals true. And what that's going to do is just place this plot right on top of this plot without making a new plotting window. But if we do that, just like this, you'll see it's a little bit of a mess, right? We got axes over each other, and the axis is wrong here. So we're going to have to adjust what we're doing here. So the first thing we want to do is make sure our x limits on our x limit is going to be the range of our year. Remember, year, this capital year here, was the x-axis for this guy. So I want to make sure that we have our new plot on the same x-axis. So if we run this again, you'll see that, yeah, okay, so now we've moved our, since we knew that our data here started in 2002, that looks like that lines up there. We still have some axis issues here that we're gonna clean up. So we're gonna come back over here, and we're gonna turn our axes off. Axes equals false, and x label is gonna be nothing. Y label is gonna be nothing. And let's run this again. Okay, now we're getting there. Here's mean sea level. We recognize that. The year looks okay. Here's our new data on that plot. We need to add an axis here. So that's what we're going to do next. So we're going to do a command called axis, and it's going to ask for, well, you should be able to see. I can get that to come up again. Maybe not. I'll just do question mark axis. It's going to ask which side. And the side, that's our first argument, is you want to axis on 1 below, 2 left, 3 above, or 4 right. Well, on this plot we need 1. Let's click on the plot window. We need it on the right side. So we're going to put axis equals 4. Let's see what we got here. Alright, so far so good. Looks like we're getting there. Okay, what else do we need? Okay, so that looks okay. Let's go ahead and add some points to this, which is now going to be our Antarctic mass year, and our Antarctic mass type equals L. Actually, we should properly just call it a set of points. This is called lines. I'm going to put lines on there. Line weight equals 4, and our color equals blue. So this is now going to add a line onto our active plot, which is the window that is writing, you know, for this axis over here. So that's still writing in our par new equals true. So now we got our sea level rise, and we got our Greenland mass loss and our Antarctica mass loss. Okay. Now we just need to add a text over here, and we're going to use that using mtext. Stands for margin text. So we're going to write text on our side, and this place is going to be 4. So we're going to write our text. We're going to put it on this side over here. So if we do mtext, I'm sorry, put this up here. Since April 2002, this is in gigatons. Okay, the side is going to be 4. That's our fourth side over there. And the line equals 2. That's how far off the axis that we want it. So if we just add this, all right, there's our ice mass loss. There we go. Okay, we're starting to look pretty good. The last thing we need to do is make a legend, because it's hard to know, right? So we know that we knew that this black line goes to this side, and these colored lines go to this axis, but we just need to make that clear in the legend. In a legend. So here we go. Let's make a legend. Put it on the top left. Global mean sea level. Greenland ice mass, that's the next one that we want. And the next one is line weight equals 4, color equals, let's see, we need black as our first color, that was our sea level. Then we need sea green 4, there's lots of colors you can choose from, you can look them up. And blue, okay. Alright, what does that look like? Okay, looks like it covers some of our data there, so we're going to change a few things up. Let's try putting a box type equals no box around it. And let's see, let's go ahead and run this all the way from the beginning up here from where it says par. Okay, now you can see we got to shrink it a little bit, so that command is cex equals 1 is the default, so we're going to put it at 0.7. We'll run everything again, and there we go. Now you know, the reader knows. Global mean sea levels here, Greenland ice mass is this one, Antarctic ice mass is that one. And the question is, do these things seem related? Okay, that's all we've got. Make sure you save your code, and you can ask yourself some critical questions about how these things might be related and whether or not they're accelerated.